Welcome to the deep dive. Today, we're looking at a really fundamental shift in AI, moving from systems that, well, think to systems that actually work.
Yeah, it's this idea of the age of AI agency, as the source material calls it.
Right. So, what does agency actually mean in this context? Is it just smarter AI?
It's a bit more than that.
Hmm.
Agency is this emerging ability for AI systems to be autonomous agents. So they're not just responding, they're actively finding problems, thinking up hypotheses, and then, executing solutions.
How do they do that? Through interacting with tools in their environment.
That's the idea.
Yeah.
Self-directed engagement, it's moving from passive calculation to proactive problem solving, real collaboration potential there.
Okay, but the usual path for getting better AI, the one we've heard about for years, is just scale, right? More data, bigger models. That's been the mantra.
It has. The assumption was always that more data naturally leads to better agency, following the same scaling laws we saw work so well for language models.
But the research we're digging into today throws a wrench in that.
It really does. It introduces this approach called LIMI less minds is more for intelligent agency. And the core idea is pretty radical.
Yeah.
It suggests agency develops very differently.
Okay.
The fascinating part is how they got there. How this really sophisticated Asian intelligence emerged from just a handful of examples.
And when you say a handful, you mean really small.
We're talking about achieving significant results with just 78 training samples.
78, that's
Yeah.
tiny compared to the billions or trillions of tokens usually involved.
Right. And it builds on some earlier hints we saw. Remember LIMA? That showed you could get good alignment with maybe 1,000 curated examples.
Quality over quantity for instructions.
And then Limo pushed it further in reasoning, showing a 45% jump in math reasoning with only about 800 samples.
So those were pointing the way. And LIMI takes that idea that less high-quality data can be more and applies it squarely to this concept of agency.
That's it. It leads to what they call the agency efficiency principle. Basically, that real machine autonomy doesn't come from drowning the model in data.
It comes from strategic curation, picking the right demonstrations.
Precisely. High quality, really information-dense, agentic demonstrations. It's about the instructional value, not just the volume.
Okay, so where did they focus this curation strategy? What kinds of tasks?
They targeted two big areas that cover a lot of, knowledge work. First, collaborative software development, they call it vibe coding.
Vibe coding, like the back and forth between a developer and an AI pair programmer.
Sort of, yeah. Capturing that fluid interaction. And the second area was complex scientific research workflows. Think multi-step analysis, hypothesis testing, that kind of thing.
So highly complex, multi-turn tasks, which brings us back to the 78 samples. How on earth do you make 78 samples powerful enough? What was special about them?
Well, it wasn't just grabbing 78 random interactions. They had three key innovations in how they created this data. First was novel query synthesis.
Meaning they crafted better starting problems.
Yeah, they didn't just use generic prompts. They mixed human-AI collaboration with something really interesting. Systematically synthesizing queries using GPT-5 based on actual complex pull requests from popular GitHub repos.
Ah, so the problems themselves were grounded in real-world complexity.
That's the goal. Get the richness of real coding challenges. That's the query part. But agency is about the whole process, right?
Right, the journey, not just the start.
So the second innovation was systematic trajectory collection. They developed a protocol to capture the entire interaction sequence, every turn, every command, every output, all within their command line environment.
So not just the final answer, but every step, every dead end, every tool used along the way.
Exactly. It's like showing the full working out process, not just the solution in the back of the book.
Okay, and the third piece. You mentioned trajectory formalization. Sounds technical. What does that actually log?
It sounds complex, but the idea is simple. For every single action the AI takes in the trajectory, the data logs three key things. First, the model reasoning, basically. Its internal thought process, why it chose that action. Second, the model tool calling, which tool it used, what parameters. And third, the environment observation, what actually happened as a result, the feedback.
I see. So the model learns the why and the what happened alongside the what to do. That makes the data much richer.
Much richer. And that explains why 78 samples could work. These weren't short snippets. The source material notes the longest trajectory was huge, 152,000 tokens.
Wow.
And the average was over 42,000 tokens. These are incredibly dense learning signals packed into each sample.
Okay, that makes more sense. It's not 78 simple prompts. It's 78 incredibly detailed case studies of problem solving.
You got it. That density is the secret sauce. Now let's talk performance. On Agency Bench, which is a pretty comprehensive test suite, LIMI scored an average of 73.5%.
73.5%. How does that stack up against more traditionally trained models?
It's a big jump. The baseline comparisons are striking. GLM 4.5 got 45.1%. Qwen 3235B was down at 27.5%. Kimi K2 at 24.1%. And DeepSeek V3.1 even lower at 11.9%.
That's a huge gap. But wait, with only 78 samples, couldn't it just be that LIMI got really, really good at those specific kinds of problems? Overfitting, basically.
That's the critical question always with small data sets. Did it just memorize or did it generalize?
Right.
But the other results suggest it really did generalize. They tested LIMI on a bunch of different unseen benchmarks like standard coding tests, EVL+, and tool use tasks, TAU2.
And how did it do there?
It achieved a 57.2% average across those diverse benchmarks.
Mm.
Importantly, it still outperformed all the baseline models on these generalized tasks, too.
Okay, so that suggests it learned underlying principles of agency, not just the specific training examples.
It seems so. It didn't just memorize the answers, it learned a better way to find answers.
And that data efficiency point is just,
Yart.
you said 73.5% performance versus something like 47.8% for model trained on 10,000 samples.
Yeah, like the GLM 4.5 code baseline.
Yeah.
So LIMI got over 50% better performance using, 128 times fewer samples?
That really drives home the agency efficiency principle. Less data, but much smarter data, yields vastly better results.
And it wasn't just about eventually getting the right answer. They looked at first-turn functional completeness, FTFC.
Getting it right the first time.
Basically, yes.
Yeah.
How often does the agent solve the task correctly on its initial attempt without needing hints or corrections? LIMI showed a massive improvement there to nearly 34 percentage points better than the best baseline.
Which suggests a deeper understanding from the start, not just trial and error.
That's the interpretation, a genuinely better grasp of the problem space.
Okay, let's make this concrete. The sources had some case studies, right? Comparing LIMI to a baseline on actual tasks.
They did. Take the vibe coding example, task 3, building a web-based Gomoku game.
Okay, like a classic board game. What happened?
The base model, GLM 4.5, really struggled. It had trouble just rendering the board correctly, figuring out wins and losses, and it got completely stuck trying to add different AI difficulty levels. Needed a lot of human intervention.
And?
LIMI sailed through it, completed all the subtasks, including the different AI levels, with no interactive hints needed.
Wow. That's the difference between a tool you have to constantly guide and one that can actually take initiative.
Exactly. Or look at the scientific research workflow example, task 8, scientific function discovery. The job was to find equations that fit some complex data, aiming for a really small error or loss.
Okay.
The base GLM 4.5 model needed multiple tries, lots of interaction, and eventually got the loss down to about 1.14 times 10 to the minus 6.
Which sounds small, but
But LIMI, on its very first try, achieved a loss of 5.95 times 10 to the minus 7.
that's an order of magnitude better, right off the bat.
Right out of the gate. Shows much better initial hypothesis generation, much better understanding of how to approach the scientific problem.
Were there examples needing more, like, complex reasoning and pulling info together?
Yeah, task 9, the NBA search example. This involved digging through info about player trades, figuring out complex scenarios.
Tricky stuff.
The base model often needed nudges, like it might guess the wrong player initially, say Victor Oladipo instead of Paul George, and need a human prompt to get back on track. LIMI was correct more often, and importantly, even when it was wrong, it could self-correct much more efficiently. Fewer steps, fewer tokens used in its reasoning process to find the right answer.
So faster, more efficient reasoning, even during correction.
It suggests a more robust internal reasoning engine built from that curated data.
Okay, so pulling all this together, what's the big takeaway here?
I think the research really confirms this paradigm shift we talked about. Developing truly capable agentic AI isn't necessarily about building the biggest possible model and feeding it the entire internet.
It's about the data.
It seems the key lies in strategic data curation, creating these incredibly dense, high-quality examples of complex, self-directed problem solving. It's about distilling the essence of agency, not just accumulating raw experience.
Quality over quantity, writ large for AI agents. Here's a final thought, then, for you listening. The researchers didn't just test this on a giant model. They applied the same curation method to a much smaller one, LIMI, about 106 billion parameters.
Hmm.
And even on that smaller base model, adding these 78 curated samples led to a huge jump, a 17.3 percentage point increase on agency bench compared to its untuned counterpart.
Still a very significant improvement.
So if this high-quality curation works well, regardless of the model's sheer size,
Hmm.
does this maybe signal a different path forward? Could smaller, smarter teams potentially build powerful AI agents by focusing on data quality, maybe moving away from this relentless race for just bigger and bigger scale? Something to think about.